this webinar that is the last before our big congress in Istanbul in September. Therefore, I also hope that there will be many of you that will be attending the congress in Istanbul. So far, I know that I was said that there are more, at this moment, more or less 3,000 registrations. That means that it is reasonable that we can expect to have around 4,000 participants, depending on the international geopolitical situation. But for many reasons, not only for the Congress, we hope really that the situation can improve very, very soon. So the webinar of today is on Buffalo, and we have very, very outstanding speakers from different parts of the world. But I would like to leave the floor and the chairmanship, the management of this webinar to the person that organized and got in touch with the different speakers and took over the organization of this webinar. And we are really thankful to her. Is Professor Rosaihan Mansoor, that is Associate Professor at the University Putra in Malaysia, and he is member of the Board of Governors of the World Association for Buiatrics. Therefore, after having asked everybody to mute the microphone, to switch off the microphone, I would like to ask Rosaihan to take over the chairmanship of our webinar. Rosaihan, please, the floor is yours.
Thank you, Prof. Arcangelo. Good morning, good afternoon, and good evening to our wonderful global audiences joining us from all around the world. So welcome to today's WAB webinar, which is proudly organized by World Association for Buiatrics and co-organized by the Malaysian Veterinary Medical Association. So as we can see, we are focusing on buffaloes today, right? And we have a great groups of speakers that we have invited, which we will talk about practical cutting-edge strategies for buffalo health, reproduction, and also system sustainability. So my name is Rosaihan. Welcome, everyone. I'm from Malaysia. I'm teaching in University Putra, Malaysia. So a few housekeeping notes for all participants. We will be issuing your certificate of attendance. And I think Dr. Peter has shared the Google form link, which you can click and fill in your details. And we will issue the certificate after this webinar. And you may also, I think, collect your CPD point if needed by your veterinary council, veterinary association later. And I think we can have our question and answer session right after all three speakers have presented their presentation. So I would like for all participants to mute your mic before we move on to our very first speaker. Allow me to introduce our first speaker, which is Professor Dr. Pietro Baruselli, who will be speaking on the topic of impact of reproductive biotechnologies on reproductive efficiency and productivity in buffalo farms. So a bit introduction for Professor Baruselli. So he is a professor of animal reproduction at the University of Sao Paulo in Brazil. So basically, he served as the president of the Brazilian Embryo Technology Society from 2012 to 2014. Also, he used to chair the 45th Annual Conference, and his extensive research and teaching focus is on follicular dynamics and ovulation for fixed-time artificial insemination and embryo transfer in cattle and buffalo. So with this, please welcome Professor Dr. Pietro Baruselli. The virtual stage is yours. Thank you.
Okay, thank you very much, Professor Rosanna. First of all, would like to thanks. It's an honor for me to be here with you, sharing some information that we we have here in Brazil regarding to buffalo reproduction. That's my area. So I work at the São Paulo University, as Professor Rosana present me. So thank you for the World Association for Buiatrics also to invitation. So I will talk about the impact of reproductive biotechnology in reproductive efficiency and productivity in buffalo farm. So we start to study buffalo reproduction here at university around 40 years ago. So I try to share you the most important information that I think that is important to discuss with you. Okay, so this is the just to start. So just to show, we have several buffaloes in Asia, in India, in Pakistan, in China, in other countries of Asia, but we have also buffalo in Americas. So we can see here that we have buffaloes in different countries of America, in all countries, 100% of countries in America, in South America, in Central America, in North America, we have a buffalo. So here at University of São Paulo, we start to study the possibility to use biotechnology for production buffalo years ago. So this is the introduction. So using artificial insemination and embryo transfer is very important for our breeders because we increase quickly the genetically of the animal, we increase the productivity, as you know. And we will share you some particularities of ovarian physiology in buffalo that I think that's important to understand, to use biotechnology for production, some information about artificial insemination, the problem of issues detection to do artificial insemination, and the study we did using synchronization, try to improve the efficiency of artificial insemination. And I will talk also about a little about embryo transfer, in vivo and in vitro embryo transfer, some conclusions to discuss with you. So this is a study we did trying to understand the reproductive physiologic during the estrous cycle in buffalo. And we can see that buffalo presents several very similar follicular wave and the estrous cycle compared to cattle. So they have a predominance of two waves of follicle growth during the cycle, but they have also kind of three waves or four waves, so it's very similar than in cattle. But the number of recruited follicle per waves, normally when we compare the same simple situation, temporal study using cycling heifers here at São Paulo University, you can see here that the buffalo present a smaller number of follicle recruited per follicular wave compared to other species, mainly compared to zebu that present a high number of follicle recruited per wave. So this is important mainly for embryo transfer. So when we are doing ovum pickup to produce embryos by in vitro embryo transfer. So we study also markers, so endocrine markers, and we can see here that buffalo present a variation between number of follicles during the follicular wave, but we have an endocrine marker like anti-millennium hormone that's the effective markers for embryo population. So you can see here in all these species in buffalo, so we can select the animal using biological marker, and as I show you. Another important difference between the reproduction comparing cattle and buffalo is the seasonality, the reproductive seasonality in buffalo. Studies in Italy, mainly with Professor Ziccarelli, show that buffalo present a sexual activity when decrease the daylights, mainly in summer and early autumn. But this depended of the size of the farm, depend of the location of the farm. So different latitudes of the distant from Ecuador, like Ecuador and latitude 32, is a study we did with 6,000 buffalo. You can see here that as we have a distance from the Ecuador, increase reproductive seasonality become more pronounced. Look here, when we have a latitudes like 24, 32 from Ecuador, we increase the concentration of the calving arriving like 8% in 3 months. As distant from Ecuador, more seasonality we have. So this is a strong difference than in cattle, that we don't have a reproductive seasonality. So to use AI trying to multiply paternal lineage to include genetically or embryo transfer, when we introduce the paternal and maternal lineage to genetically improved, I will start talking about artificial insemination. So we have a limited use of AI in buffalo, mainly because we have a low service rate. We have a difficult to detect issues because the buffalo normally they don't have homosexual behaviors. It's very difficult to detect the issues. We have seasonality, the seasonality that I talk with you. We have a postpartum anestrus that mainly related with nutrition, and we have also delay of puberty. So all this problem here make it difficult to use AI. So what we contribute here with our research in São Paulo University, we start to detect, to induce the ovulation using protocols for fixed time artificial insemination. This is a study we did years ago in 1999, at the end of 90, when we tried to use in buffalo the OV-Sync protocol that Milo Wiltbank developed in Wisconsin. So we study all the follicular dynamics in buffalo using this protocol, and we use this protocol for do AI in a large amount of buffalo, near 1,000 buffalo, and look that we can have it in one AI nearly 50% conception rate during the breeding season. But when we have a off-breed season, this protocol have a very low efficiency. Look here. So the OV-Sync protocol works if the buffalo are cycling during the breeding season, but when they are not cycling, it not works very well for the farmers. So we try to study other protocols using progesterone, different than OV-Sync that use generator prostaglandin, use progesterone, look at progesterone and estradiol. And when we did this study, we found that we can have a high efficiency in the breeding and non-breeding season, showing that the farmers today, they can have the same reproductive efficiency through the year using fixed time AI. So this is a very important information. But in countries that we don't have estradiol, you can use the OV-Sync in an estrus buffalo, but using together with the OV-Sync, the intravaginal progesterone device between generator and prostaglandin. So using this, you can see here in 500 buffalo that we synchronized, we can have in the early postpartum, 50% conception rate. We resynchronize using ultrasound the non-pregnant cow. We have 54 in the second. We resynchronize the non-pregnant buffalo using ultrasound. We have 30%. So we can have 8% pregnancy rate, 12 months intercalve interval using 3 AI in buffalo. So reproductive efficient genetic improvement. So the farm today, they have this possibility. So we talk about AI, but now we will talk a little about embryo transfer. So the embryo transfer, we increase the intensity of the selection because we use the best female and the best male to produce embryo, and we introduce these embryos in animals with low genetic production. So, but when we did the study using in vivo embryo transfer, the reproductive efficiency of in vivo embryo transfer in buffalo years ago was very low. So what we did a several study, a slot in buffalo, and we found that a failure to a site to enter in the oviduct in supraovulate buffalo, and it made the use of in vivo embryo transfer unfeasible in buffalo. So after this study we did it 25 years ago, we start to produce buffalo by in vitro embryo transfer using ovum pickup and the production in the labs of the buffalo. So this is a study we did. So we can see here that of comparing the species, the temporal study, when you use zebu, of course, Bos indicus, we can produce a large amount of embryos. We know about that. But the buffalo and the Holstein is more or less the same. They have a low efficiency compared to zebu, but they have similar efficiency. So this study is important to show that it's possible to produce embryo by in vitro. And of course, we know that you have factors that interfere in the embryo production. One of the factors is the individual significant
I lost
individual variation among both. So if we select the animals with a high follicular population, of course, we improve the amount of embryo produced per OPU. So we have also a possibility to select the antral follicle population, but we have also an endocrine marker like AMH. So we did a study also showing that when we have a high circulating IMH, you have a high follicle aspirate, high oocyte collect, and high embryo production. So this is just to know that it's possible to improve the efficiency using selecting animals that have a high follicle population in the ovary. And we so can using a super stimulation prior to OPU to produce more embryos. We are finishing.
Yeah.
Okay, we are finishing. Okay, but what we showed that we have an endocrine marker to select donor as AMH that we studied the AMH as a marker, and higher is the AMH, higher is the embryo production in buffalo, and we can also treat the buffalo with FSH, trying to improve the embryo transfer, showing here that if we use FSH, we can improve the medium and large follicle. That's important to quality of the oocyte. We improve the viable oocyte rate, the blastocyst rate, and the embryo production per OPU. So using FSH in the donor, buffalo donor, could improve the efficiency of embryo production. And now, just to show you that we can also use donors, young donors like calves, as a donor using in vitro embryo production. So this is a study we did here at São Paulo University also, trying to reduce the generation interval and increase genetic gain using young donors, prepubertal donors or calves. So what we did, we using laparoscope to collect the oocyte, the ovum pickup of the oocyte, using also FSH, trying to super stimulate the calves. And after transfer these embryos 10 years ago, we produced a large amount of calves produced by calf. So what's this? The intercalving between generation decreased for 1 year, increasing the genetic gain of the buffalo, using also today the genomic and other possibility. And then you can also use in buffalo sex semen. So you use sex semen to produce females with high genetic and young animals, trying to improve the efficiency. So, and we also developed a fixed time embryo transfer protocol. So today we use a protocol to synchronize recipients with high efficiency. So we do the OPU and we develop the embryos, and we can transfer the embryo fresh or frozen using fixal time embryo transfer. So this is a high genetic potential. So in the IT is contributing to the milk production. So this is a study we did in the same farm, in the same situation. We take cows produced by embryo transfer or for artificial insemination or natural mating. And so, of course, because we have a strong increase in genetically when using embryo transfer, the milk production improve when we use embryo transfer. So the calf born by embryo transfer produce more milk than the other biotechnological production. And finishing, just a history here for São Paulo University, we produced in 1994 the first buffalo produced by in vivo embryo transfer. In 2005, the first buffalo produced by in vitro embryo transfer. And in 2006, we produced calves produced for calves, for donor with 4 months, just to understand a little the history. And in conclusion, reproductive technology has here been progressively refined in buffaloes, and today the use of AI and in vitro is compared to cattle. This is very important to the buffalo breeders, né? To have a comparison. So currently it's possible to establish efficient problem for use art in buffalo, improve reproductive efficiency and genetic selection, an important strategy for use of dairy and buffalo beef industry. So this kind of biotechnology is contributing to the buffalo industry in the world. So, and finishing, I would like to thank all my master and PhD students that during these 40 years help a lot to develop this study, and the collaboration, the World Association for Buiatrics, thanks again for the invitation, the Brazilian Buffalo Breeders Association, thank you very much also, because we strongly work directly with the breeders here in Brazil, and some professor that did a study with us, Professor William Valle, Professor Luigi Ziccarelli, Dr. Nelson, the breeder Otávio Bernardes, and thank you for all. Thank you for the World Buiatrics Country, Professor Ricardo, also to invite us. It's a pleasure. If you have any question, we'll be here to discuss with you. Thank you very much.
Thank you so much, Professor Baruselli, for that absolutely brilliant and comprehensive presentation. I mean, you can actually see like why your decades of pioneering research at the University of Sao Paulo have made such a profound global impact on buffalo reproductive management. So if you guys have any questions, you can just put it in the chat box, and if we have time, we can go through your questions and let Professor Baruselli to answer your questions. Thank you very much, Professor. So next, we move to our second speaker, Dr. Antonio Natale. So a bit about Dr. Natale's background. He is a dedicated Buiatrist with a remarkable 30-year career deeply rooted in large animal fieldwork and reproductive science. He is highly regarded as an expert in herd health management at scale, masterfully integrating veterinary medicine with agronomy to optimize livestock welfare and farm productivity. So please, Dr. Natale, the floor is yours.
So we see your screen.
Yes, we can.
Please open your mic.
Antonio, your microphone. Antonio, yeah.
Now it's open.
Adesso, Antonio.
Okay. Sorry.
No, it's fine now.
Good morning. First, I must apologize for my English, which is not perfect. I would like to express my deepest gratitude to my esteemed co-supervisor for this global webinar, Prof. Pietro Baroselli of the University of São Paulo, a world-renowned authority, particularly in buffalo research, and Dr. Shuvo Singha of the International Center for Diarrheal Disease Research, whose myriad publications are indispensable to the zootechnical community. I am also profoundly grateful to Prof. Razaya Mansour, representing the Malaysian Veterinary Medical Association and the WAB board member, whose presence was fundamental to make this event possible. Last one, but certainly not least, a special and a heartfelt thank you to my mentor, Prof. Arcangelo Gentile, President of the World Association for Buiatrics. Dear Buiatrics colleagues from all the world, welcome and thank you for your attention. The dairy buffalo sector is experiencing explosive global growth, with production rising by roughly 13% over the last decade. This expansion is driven by high-value added supply chains, such as mozzarella di bufala campana, PDO in Italy. Yet as clinicians and managers, every day we run up against a biological commercial paradox. It is by now well known that the buffalo is a seasonal breeder, a short day, negative photoperiod species that expresses maximum fertility in the autumn and winter months. Market demand for mozzarella, on the other hand, peaks in spring and summer. To align production with the market, we force out of season breeding. This is seasonalization. This friction chase is the root of our health, reproductive and metabolic challenges. Today we will discuss the most effective strategies to increase productivity, improve animal health, and promote ever more sustainable farming system. There is a widespread but dangerous belief that the buffalo is an extremely rustic and metabolically invulnerable animal. Nothing could be further from the truth. Although the buffalo shows a lower clinical incidence of metabolic disease than the high-yielding dairy cow, negative energy balance during the transition period is one of the main hidden causes of lost income and reduced fertility. I want to stress that over the last 10 years, in our field, clinical practice, we have been seeing a significant rise in the metabolic disorders that are typical of high-producing dairy cow. I offer the following as a field observation, a hypothesis to be verified, not established data. in the most intensive hertz, pushed her on desazonalization, we are perceiving an increase in conditions that were once rare, retaining placenta, endometritis, hypocalcemic forms, and occasional left and right side abomasal displacement. I emphasized perceiving. If this trend is real, we must measure it with systematic records and prevalence figures, because a recent surgical caseload of abomasal displacement in the buffalo would in itself be a scientifically relevant finding. This is exactly the kind of signal that herd management must turn from an impression into a number. Reading the liver, one enzyme is not a diagnosis. The buffalo adapts its metabolism to meet the enormous energy demands of early lactation. But when that adaptation fails, we face subclinical ketosis. The most serious mistake we make in the field is to apply dairy cattle parameters to the buffalo. In the dairy cow, the threshold of diagnosing hyperketonemia is a serum beta hydroxybutyrate level of 1.0 or 1.4 mmol. For the buffalo, by contrast, a validated diagnostic threshold has not yet been established. A metabolomics study on the Mediterranean buffalo divided the animal using a work cutoff of 0.70 mmol. Above that value, significant metabolic alterations were already appearing. This is a valuable datum consistent with the idea that the buffalo reacts at lower BHB level than the cow, meaning that in the buffalo we are already at risk of hyperketonemia at BHB value of 0.70 mmol. Managing that transition. What is happening in these animals? The proton spectroscopy analysis in that study identified about a dozen altered metabolites attributable to body reserve mobilization, ruminal fermentation, the urea cycle, thyroid function, inflammation, and oxidative stress. On the hepatic side, we find indicators of distress from lipid infiltration. A clinical caveat asterisk, but is not liver specific. It is also abundant in the muscle. The truly assess the liver, we should pair it with more specific enzymes such as GJT and JLDH, and read them together with NEFA and BHB. In the buffalo, a single non-specific enzyme does not make a diagnosis. Breeding off season, two distinct enemies. How can we apply nutritional management in practice to prevent this metabolic collapse? We must act on the diet, steaming up, the switch from on the dry diet to the lactation diet must not be abrupt. We should form a close-up group at least 3 weeks before curving, raising the energy density on the ration to about 0.90 milk forage units per kilogram of dry matter and bringing protein to 13%. Number 2, phosphorus and prolapses. One of the most devastating conditions in the buffalo is prepartum vaginal prolapse and postpartum uterine prolapse. The principal case is not mechanical but metabolic and phosphorus deficiency during the dry period. Careful calibration of the calcium-phosphorus ratio, keeping P stable, in the months before calving is the most effective preventive weapon at our disposal. Number 3, the general principle. Preventing periparturient metabolic disorders is not a clinical detail. It is the foundation of farm productivity. Every buffalo that enters lactation in metabolic balance is a buffalo that will breed back on time. And this is crucial for farm profitability. Functional luteopathy support the corpus luteum. Modern insight into reproduction. Reproductive success is a direct product of metabolic health. Buffalo with a low body condition score due to a poorly managed transition face delays in the resumption of ovarian activity and drops in pregnancy rates. Let's see how, if we inseminate buffaloes during the unfavorable season, spring, summer, to serve the supply chain, we have to contend both with the species' low fertility and above all with late embryonic mortality. Age at first calving and economic lever. During the months of increasing photoperiod, there is a collapse of the vascularization and function of the corpus luteum with progesterone. Secretion insufficient to maintain embryo implantation. This is not an infection. It's a functionally luteopathy. Winning practical strategy involve integrating luteal support in the synchronization protocols. For example, intravaginal PRID or CIDR device combined with HCG and PMCG to force development of the dominant follicle and cut embryonic losses. Sustainability as a clinical name, prevention. Another enormous economic lever at our disposal is age at first calving. A buffalo heifer must be fed rigorously but when adding growth in order to conceive at the right time. Data on more than 27,000 lactations show that the optimal AFC, the one that maximizes the farm's net profit, between 35 and 38 months. Calving before 30 months leads to physiologically immature buffaloes, traumatic problem during the expulsive phase of calving, lower milk production, and lengthened calving intervals. While the lying beyond 42 months destroys profitability through the accumulation of unproductive rearing costs. When we are talking of sustainability in TV studies today, the narrative is often light years away from the reality of our barns. But we veterans know very well that true sustainability in animal husbandry is not an abstract concept or a fashion. It has a clinical name, and that name is prevention. Biosecurity and veterinary health management are the two fundamental pillars of modern preventive veterinary medicine and of the sustainable management of livestock farms. Biosecurity is defined as the set of preventive, managerial, and structural measures adopted to prevent the introduction, spread, and persistence of pathogens within a farm. BHHM is an approach in which husbandry and clinical attention take a step up in level. It moved from treating the single sick animal to managing and preventing at the level of the entire herd. Under this paradigm, the role of the veterinarian changes radically, evolving from a mere tending clinician called for emergency into a true strategic consultant for farm management. BHHM programs are based on regular scheduled farm visits, during which the veterinarian collects, monitors, and analyzes husbandry data. Our role is no longer only that of the firefighter called at 3 a.m. for a full-blown clinical emergency. Should a health problem fail to remain confined to the single individual and instead extend to a significant share of or the entire herd, we would be facing a genuine systemic collapse. In such an epidemiological scenario, the effectiveness of therapeutic interventions drops sharply, triggering a cascade effect that culminates in devastating and often irreversible financial damage to the farm's economic viability. Today, the pediatric veterinarian is the farm strategist. Using precision livestock farming, we are able to read the drop in rumination of a cow or buffalo day before it manifests ketosis or collapse. By integrating these early alerts with rigorous biosecurity plans, we collapse the need for antibiotic therapies, placing ourselves on the front line in the fight against antimicrobial resistance. And to do this, we must unite our oldest clinical tradition with the utmost technological innovation. Colleagues, to unlock buffalo productive and make it sustainable, we must stop managing emergency and start managing data. First message, the buffalo is not immune to metabolic problems. Subclinical ketosis in the buffalo begins at BHB threshold 0.70 mmol, much lower than in keto. Let's actively monitor the periparturient period and introduce nutritional steaming up. Number 2, let's defend the reproduction. Let's manage a dry period phosphorus to zero out prolapse and support the luteal phase in summer breeding protocols to defeat embryonic mortality. Message 3, let's optimize the start of a curve. Let's aim for an age at first calving of 35 or 38 months to ensure maximum economic return, other health, and the longevity of the animal in the herd. In short, sustainability and the protection of supply chain begin in the barn with preventive medicine. This is the veterinary herd health management of the future. Thank you for your attention.
Thank you very much, Dr. Natalie, for that outstanding and highly practical presentation. To our audience members, you can always put your questions in the chat box. In case we don't have time to answer all questions, please drop your email so that we can follow up with your questions later. Thank you once again, Dr. Natalie, for sharing your incredible clinical expertise with us today. So next, our third and final speaker. Yes, Prof. Angelo? You're not saying anything? All right, so our third and final speaker for today is Dr. Shubho Singha. So he will be guiding us through his presentation. But before that, allow me to introduce Dr. Singha. He is an accomplished public health epidemiologist and a veterinarian, who has a robust background in driving mixed methods research. He also manages high-impact epidemiological projects, working at ICDDRB, which is like a very long name there. So without further ado, we look forward to your presentation. Dr. Singha, the floor is yours. Thank you.
Okay, thank you, Professor. Am I audible? Yeah.
Yes, we see your screen.
Sir, am I audible? And can you hear my slides?
Yes,
We see
perfect.
your slides and we hear you. It's all fine.
Okay. 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 Thank you very much. So, welcome everyone. I want to convey my special thanks to the organizers, especially Professor Roseanne, for inviting me this webinar organized by World Association of Buiatrics and the Malaysian Medical Association. Especially so many experts on otter buffalo from different corners of the world. And it's also honor to share this speaking opportunity with Professor Pietro and Dr. Antonio. And also it's a pleasure to see many of my colleagues from different countries and also my professors here. So today I'm going to present some of the key research experience from my past few years of collaborative research on otter buffalo in Bangladesh. So this will basically cover the animal health perspective, mainly udder health and some infectious diseases, also food safety, and importantly, some key challenges we identified through participatory approach and also some solutions for system redesign. So, Bangladesh is a small South Asian country that comprises almost 64 districts, and about 13% of its national GDP comes from agriculture, and livestock is also a major contributor here. So, if we look at the minimal target for daily milk availability, there's still a large demand supply gap there. And to reach there, if we see that over last few decades, there's a substantial intensification of dairy cows has been made. However, otter buffalo are partly neglected actually, and potentials was not fully exploited. So, if we look back at the neighboring South Asian countries, for example, India, Pakistan, then we can see that Bangladesh lacks in the global buffalo milk production, especially, and therefore there's still some room for improvement to meet this large demand supply gap if we can focus in otter buffalo dairy chain in Bangladesh. So currently, Bangladesh has about 1.5 million buffalo heads in Bangladesh. They are mainly distributed in coastal and semi-coastal areas. And if we see in the right graph here, we can see almost all the districts have buffalo population in Bangladesh. But in the indigenous buffalo breeds that are available in Bangladesh, they are low milk producers. They're considerably lower if we compare it with the many buffalo breeds that are available from the buffalo producers that are dominating countries in the world. And importantly, per animal milk yield in Bangladesh is very negligible. So this is on key constraints. So interestingly, buffalo production system in Bangladesh is a little different, as many of already know that. So we can divide it into two basic geographical locations. One is island-based and another one is inland-based. So in island, there's a feed-in system is the most common, and locally a farm is called bathan. And in a bathan, usually 50 to 600 buffaloes, cows, and sheep, they live together, and they are mostly dependent on grazing and with or without minimal concentrate supplements. So these bathans again, they close by are called a killa. So some farms like a community, a small community, and then all these killa from the buffalo population on this island. There's many island like this. And this, on the other hand, in inland, there are several other rearing system. For example, semi-bathan system. So it's connected with bathan. So buffaloes from in island comes here when there's nothing to feed in the island. And then inland intensive systems. So they're tied. Animals are tied in the shade, and they're more or less like dairy cows in the in South Asian countries. And then household, only few buffaloes are reared in household, maybe 1 to 10. And semi-intensive system is a combined system. So the animals stay at household, nearby household, they go grazing and then come back every day. Now, because the farms are very remotely located, especially in free engine system, so there are very poor communication facilities, and there's inadequate milk cooling facilities, and finally there's a very long transportation time needed. So this can pose potential risk for microbial contamination during transportation and handling of buffalo milk at post meal production phase, and also the traditional nasal fermentation of raw buffalo milk that is generally used produced from unpasteurized raw milk. So that can also contribute to significant microbial contamination. So therefore, there is a significant risk of transmission of foodborne zoonotic pathogens, especially so that can threat to many public health safety of the large scale consumers. However, we knew very little about this buffalo milk chain operations and also microbiological safety aspect. So to focus on these problems, we collaborated a 4-year research project that was titled Climate Change Mitigation by Sustainable Otter Buffalo Milk Chain in Bangladesh, so which was funded by Swedish Research Council and in collaboration with research organization and institutes from several countries. So this research project the work packages are implemented through the contribution of on PhD and postdoc fellow and 5 brilliant master's fellow there. So firstly, from animal health part, we looked at the subclinical mastitis status, which was expected much lower in dairy cows as is concerned that buffalo must be immune to many diseases. However, we found that 1/4 of the quarter and half of the animals were positive for subclinical mastitis. But importantly, we didn't see much clinical mastitis in otter buffalo. But we don't know because meal production was low, very low. So by nature, they are less means susceptible to clinical mastitis like high yield. That could be a reason. And another part, bulk meal somatic cell count, on other hand, which gives a overall impression about the other health in the farm level, that we found 200,000 cells per ml of milk, which is quite satisfactory if we compared with the dairy cows. So overall, milk quality of buffalo was far better compared to the same situation in dairy cows here. Now, we also looked at the intramammary infection by culture of individual quarter milk samples in otter buffalo. And here we can see in this figure in green color, so the non-aureus Staphylococcus and Mammarococcus species. So they're the most prevalent bacterial species in otter buffalo, what we found. However, it also varied very widely between farms. So this is indicative that a same management might not be useful for all the farm. So we need a specific pathogen specific control strategies for maintaining a better udder health. Now, about a little bit about supply chain in Bangladesh. So, otter buffalo milk supply chain basically the milk comes from inland, island and inland. And in island, the milk comes, all the mixed milk from cow and otter buffalo, they're mixed. So, no pure buffalo milk there. And on the other hand, in inland, there are pure buffalo milk and also mixed buffalo milk. And all of this comes through the transportation channels and received inland. Where if we see here in the red circle area, this is the major portion of the milk is received and processed by the household producer, but also milk product shops that are locally available, and some portion of milk are sold for the local consumers. And then some milk products, the most common one is the yogurt. That's formed by natural fermentation of milk, and cheese that comes from raw milk. And then on the other hand, same products also comes from boiled milk. So this largely dependent on the geographical regions of the country. Now, if we see about the food safety part, so we see that based on the culture methods, we looked at 4 different bacteria, and we see that the bacterial contamination actually increasing over the milk value chain. For example, farm to middleman to milk collection center and milk products, and that was actually high than the acceptable level in Bangladesh that is authorized by Bangladesh Food Safety Authority. So that was a little bit difficult from the public health safety part. Now we also looked at the foodborne contamination part, and we looked at several foodborne bacterial contaminations. So we see what happened about the E. coli. So overall prevalence of foodborne pathogens are very high in milk and milk products. And if we see the E. coli, that was very high in all the over the milk chain, and some specific pathogenic strains of E. coli, we looked at that, and we saw that they increase over the milk value chain. But interestingly, we see that Listeria monocytogenes and Yersinia enterocolitica, 2 important bacteria, they actually decreased over the milk value chain. So this is interesting that these organisms actually grow more in the cold chain. So when temperature is much lower, but in this cold chain, temperature was not maintained, and this actually helped to reduce this bacteria. This as an indication for that. And important, we didn't find Campylobacter jejuni along the on none of the samples. And for Salmonella enterica, we found very sporadic prevalence, but there's no trend over the milk supply chain. We also looked at the antimicrobial resistance and biofilm. So antimicrobial resistance, we see that the non-aureus staphylococci, they are showed marked resistant to penicillinase. Particularly, they are producing beta-lactamase enzymes about 35%. So as we expect that the antibiotic was not much used in Pyrenees areas and other buffalo production systems, but still there are some level of antimicrobial resistance. And we further looked at it by seeing some Staph aureus isolates from different parts of the milk chain nodes that is represented by different colors here. And we see that their resistance against some antibiotics like penicillin and then erythromycin, although they showed susceptibility against sulfur drugs and also tetracycline. But again, there was a quite marked antimicrobial resistance there that was evident phenotypically. And then we also looked at biofilm production. So we see all these isolates are mostly strong or moderate biofilm producers, and only one isolate was weak biofilm producers. So this gives a big scenario about antimicrobial resistance there. And then we also looked at the brucellosis prevalence there, and we found that brucellosis prevalence was much lower here, only 56. We looked at 180 on animals, and where we found that only 5 were positive based on ELISA, and we confirmed it using PCR, only 6 animals were actually positive for brucellosis. Now, based on this, we also looked at the constraints of the current systems, and we conducted a qualitative study following a participatory approach, including all the stakeholders and also the policymakers to find the key constraints. So what we found that overall there are 6 important constraints. First one are the resource constraints, and then knowledge gaps, then economic constraints, also weak infrastructure, then importantly policy gaps and climatic constraints. All these constraints actually are also interlinked in different situations. So this was very complex, and to find a sustainable solutions, we further used another participatory qualitative approach that is called reflexive interactive design, which is called RIO in Dutch. So this was used to redesign the buffalo milk chain of Bangladesh for a transition towards a sustainable buffalo milk production system in Bangladesh. So this comprised of three major steps. We followed only two here in our research. First one is the system and actor analysis, which includes identifying the key challenges and then arranging the brief of requirements to have a proper solution for each challenge. And then step two, that include the identifying the key functions of these solutions and then developing morphological chart to design the solution concept and to address these key challenges. To do that, we first had to analyze the system-led actors. So here this graph shows the system actors at different level of the otter buffalo production systems, and we focused key elements inside the red circle here. So for example, buffalo, many things are associated like buffalo, the animal, then milk, grass, then feed stuff, microorganism. At farm level, farmer, middleman, milker, and then anthelmintic, and then region level, the milk shop, milk processor, etc. So all those we considered. Based on this, we set the following goals to achieve to find sustainable solutions. So we categorized five broad goals for that. So high milk production, then economic viability, social acceptability, safe and healthy milk, and environment friendly situation. And then this also includes that the sub objective for each of these objectives, which was indicated as which are most important and which are moderately or less important at this stage. Using this, we developed four solution concepts. First one was solution A, which includes just low cost, convenient resources to have a solution and using existing resources and managemental practices, no change in the system. And then solution B, which was the feasible on, we termed it, and this includes rapid convenient technologies that can be added with local resources and existing management practices. So this includes, for example, milk quality testing. We can use a rapid portable milk analyzer that is cost effective on, and then cultivate fodder for nutritional supplement, then monitor buffalo to identify. We use the metal tags, and then other health management, we can use CMT or California mastitis test or Suffield mastitis test. We use the preventive management well to prevent infectious diseases, then pedigree and family history. And then we use solar panels so that in the transportation chain, we can manage the cold chain. And then we used boiling and manual cream separator for processing of milk. And finally, we have a high milk quality solution that includes use of some high-tech solution that is not currently available. And then there's a futuristic solution finally. So that includes all high-tech solutions that is needed for a modernized buffalo farming. Now we also evaluate this solution based on participatory approach from the experts based on our six major objective goals, and we score 0 to 4 each of this, and we see from all aspects which one is the most feasible, most important on in terms of achievable goals. And we found that the feasible on B, that includes the local resources in addition to very convenient low technologies, that are the most feasible on at this stage. So overall, what we found that subclinical mastitis prevalence was high, and there was a considerable intermammary infection in otter buffalo with antimicrobial resistance. Bulk meal somatic cell count was very good actually compared to dairy cows. And then we see that foodborne pathogen prevalence was high. We need some attention. And we also found some theoretical system solutions to address these constraints. So we can redesign the otter buffalo production in Bangladesh. So here are some achievements from this project at the end. So we have organized an international buffalo workshop in Bangladesh, which included participants and all the neighboring buffalo concentrated countries. And then we have produced on comprehensive manual, which is published in both Bengali and English and open accessible to all for veterinary students or farmers. And then we talked with the policy makers and we provided government a policy brief about the recommendations we offer and several peer-reviewed publications we have produced and also presented our research works in quite a few numbers of international conferences. Then here I want to acknowledge our bigger consortium. This is called Udder Health Bangladesh. So the collaborators from all the different countries, I cannot acknowledge them enough how they have contributed to have the research outputs we are able to present today. And I want to acknowledge especially World Buiatrics Association of Buiatrics and Malaysian Medical Association for arranging this webinar. And thank you very much for your patience and giving me this floor to talk. And I'll be happy to respond if there's any more questions. Okay, thank you.
Thank you very much, Dr. Singha, for that incredibly eye-opening and vital presentation. I've known this project, Udder Health Bangladesh, like I think more than 10 years. One of the main researcher was Dr. Mizan. And I mean, it's incredible to learn about how Bangladesh managing their milk chain supply, looking on the aspect of diseases and also the supply chain. Thank you very much, Dr. Shuvo. Right, so Professor Akanjelo, do we have time?
I think yes, we
Yeah.
take sometimes because the aspects that were presented are very challenging, and I think is one of the few occasions that we have to talk about buffaloes. So we are not used, and this is a pity for us. Therefore, I think we have some times, and perhaps there are also some questions in the chat. Otherwise, Rosaliana, you can open the discussion. You can manage the discussion.
Okay.
Please.
Right. I think questions for Dr. Antonio has been answered in the chat box. Perhaps we can go to Professor Baruselli if we can proceed. The first question, Professor, are you there?
Yes, I'm here.
All right. I think we can go for the very first questions for you, I think, from Dr. Detti from Venezuela. So she's asking, in your experience, how is the performance for IATF with sex semen? I guess that's the question.
Okay, no, the sex sim is a very important technology, of course, because we can change the percent of male and female using biotechnology of reproduction. We can use this in artificial insemination or in embryo transfer. It works very well also in IVF production. So we can produce embryos, male or female. And the semen technology, sex semen technology, we can have 90%, not 100%, 90% of male or female according the importance of the industry. So works very well. The problem of sex semen, of course, we use 2 million spermatozoa per dose. So normally you use 10, 12, 20 million when you use a conventional semen. So we have a low concentration and a little low fertility. So we expect to have 8 to 9% of the pregnancy rate we have with conventional semen. So we have a little low fertility, but we have a high amount of male or female born using this technology. So this is available for cattle and is available for buffalo. So with the same efficiency.
All right, thank you. I guess the next question is from Dr. Thomas. With regard to laparoscopic OPU, is this done commercially? If so, is there any genomic selection in buffaloes in Brazil, and what are the values you are selecting the donors for?
Very good question, because this technology need to be associated with genomic markers or genetic selection, because we have a calf. Of course, we don't know if they are good or not for milk or beef production because it's so young. So we need to associate it with genomic markers and genetic genomic markers for select the best animals to use in this OPU or laparoscopy analysis. So what we are doing today in Brazil, in other countries, we use these young animals. If the animals have lower than 4 5 months, we need to use laparoscopy. If the animal have more than 150 kilos, more or less, 5 months, 6 months, we can collect the oocyte using OPU. It is in prepubertal animals. So this is available commercially. So associating the farmers today, they have the possibility to use this technology. Here in Brazil, some farmers are using this technology to accelerate the genetic gain. So to improve the decrease the intercalary between generate and accelerate the genetic gain. So of course, the young animals, they have a oocyte with a little lower quality compared to cycling animals or adult animals. So we expect to produce lower amount of embryos than adult animals, and a little low conception rate from the embryos transfer compared to mature animals. Of course, because the young animals have an immature oocyte, but using super stimulation, using technology to improve the quality of this oocyte is available also commercially, and we are using today young animals to produce embryo to collaborate with the genetically programs.
All right, thank you. Next question for you also, Professor Baruselli. Are there any specific differences in reproductive behaviors between wild and domesticated buffaloes?
We work here with domestic buffalo. Né? The wild buffalo, we have different situations, depend of the country. So we have African, Asian wild buffaloes. Then it's of course have a difference, but we don't know exactly the difference because our experience here is only with Búbalos bubalis. Né? We have here in Brazil, we imported 100 years ago from Asia. We have Muha, we imported Muha. We have a Mediterranean Muha from India. Mediterranean we import from Italy. We have a Jafarabad, and we have also here Carabao, some buffalo. So this is the breed we have experience here in Brazil. We didn't compare wild buffaloes and domestic buffalo. We don't know exactly the difference.
Mm-hmm. All right. So I think last question for you. What strategies can be used to reduce the age at first calving in female buffaloes? Second one is, what is the average calving interval in Brazilian herds?
Very good question. This is important data from efficiency, reproductive efficiency and production. So lower is the age, best is the system, of course. Of course, we need to have a interpretation from the physiology of the animals. But today in Brazil, the buffalo are becoming pregnant normally in 2 years old, and the first calving around 3 years old. But we have the best farmings in Brazil that have a good management, that have a genetically selection for fertility and for precocitus, that we can decrease this conception rate to 1.5 years, and have the first calf in 2.5 years. This is very important to also decrease the intercalving between generation and improve the production of milk and beef, because you have a lower time to have the next calf, the next generation, and this is very important. Of course, this is related to nutrition, to genetically, to health. It's not easy to decrease the conception rate, but it's possible, and we are trying to do several studies here to trying to decrease the age of first calving to around 2 years, 2.5 years. For us, this is very important. Of course, you need to have a good nutrition, good genetically, but it's possible, and we have in some situation here some farmers that they are doing this possibility.
Thank you very much, Professor Baruselli. Right, and then I think we have one question for Dr. Shuvo. Let me see. How common the farmers get infected from brucellosis in Bangladesh?
Okay, so very interesting question actually. Yes, brucellosis is very important and especially for occupational groups like livestock farmers. But we don't have really very much data on this about dairy farmers. According to the available knowledge that livestock farmers in one study, they had zero prevalence of livestock farmers in dairy cows and goats and like this, and they showed a range like 4% to 12% like this. But it's not really available data like that, and even to our knowledge, we did it for the first time for otter buffalo in Bangladesh. Again, on another thing to consider that when there's a chronic infection or subclinical infection, then there's very low possibility that the enough amount of organism will shed through milk. So there's a possibility that we won't find all the positive cases through milk. So this is also another limitation, I would say. But actual prevalence should be much higher than that if we have a hypothesis on that and consider the limitation of this low probability of this detection levels of for brucellosis, especially in otter buffalo.
All right, thank you very much, Dr. Shivo, for your answer. I guess we reached the end of the webinar, but before we end, I would like to pass this session to our president, Professor Arcangelo.
Yes, thank you. No, I have just one question for Dr. Singh. Focusing on Asian countries, is there also attention given to buffaloes for meat production, or for buffaloes used for draft purposes, or the main focus is only for dairy buffaloes?
Yeah, it's actually a little bit different. No right or wrong questions actually, because if we see that most buffaloes are reared in free range areas, so they don't need any additional resources to raise that. Only labor is enough. And if they want to produce more milk, they need some resources and more effort like that. So what they do, they keep the animals there, they give what is available there, they give labor, and at the end of the year, they produce on calf from maybe 50 buffaloes, 50 calves. So they don't actually have concern about milk there. But now there's some intensification has been done. We have some intensive farms in the country, and also free range areas is limiting over the time, so we don't have many leftover land. So buffaloes actually shifting towards households, and now milk is important, and people is searching for good breeds, like especially some breeds are available in neighboring countries from India, so cross border areas. So people are getting interested about it in recent days.
Yeah, thank you. So thank you. Because I suppose, so I'm not so familiar with buffalo, I just eat pizza with mozzarella cheese produced from the buffaloes of Antonio. That are very good. I would say it's a wonderful and tasteful product. So thank you to everybody. I think the webinar today highlighted also the scientific opportunities that can contribute to improving buffalo production worldwide. I think that the topics today, and I should be really thankful to Rosayan, because I think that the topics discussed could really have filled an entire day of presentation, reflecting the complexity, the importance of the buffalo sector, also within our Buiatric community. Anyway, I think that the webinar today, our main goal was, and I think it is, and that has become even more evidence, that was to somehow spark interest and encourage discussion within our association on buffaloes. And we hope that, I hope personally, that this initiative will help raise awareness of the importance of buffalo production, health, welfare in our association, and to promote greater scientific engagement in this field, also without the World Association for Buiatrics. Therefore, I really thank the speaker, Professor Baruselli from Brazil, Antonio Natale from Italy, and Shubho Singha from Bangladesh. But I remind that the webinar has been registered, recorded, and therefore can be downloaded and seen again from through our webpage in the YouTube page of our association. I remind that it is possible to download a certificate. I remember that we have our Congress in Istanbul, and really I hope to see many of you there. If some of you is not in the mailing list, please send to info@buiatrics.com your email address so that we can add in the mailing list. But at the end, I would like to thank Rosayan for having decided and supported to organize this very, very interesting webinar. Thank you, Rosayan. As I told you, watch out, because I think that you will ask again in the future to organize such our webinars, but we will continue. So thank you, everybody. I think, Peter, I can close, or I need to say something more, because you are my right hand, and I need always suggestion. I always do mistakes.
No mistakes. It was a fantastic webinar, but we can close now.
Yeah, thank you, everybody from all over the world. So really, this time we have participants from all over the world. Unbelievable, unbelievable. Thank you. See you next time.
See you.
Thank you very much.
Thank you, all the speakers. Bye bye.